What's going on, guys? Today we're going to learn about quadratic functions as it shows on the screen. This is one of the biggest concepts in all of integrated mathematics too. It's a big concept that helps you a lot whenever you go into all of the rest of mathematics. The biggest concept you learned up until now was probably linear functions, which is also arithmetic sequences, for example. So that's a huge piece of IM1, but that's going to be used forever, and that's why we've reviewed it. And it also ties in hand with quadratic functions. So with that being said, I'm showing you on the screen this picture of a motorcycle rider. He's going in it looks like an arcing motion, right? Um, and it's showing every different position that he is in his jump. And so he goes up, 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 and then you can see him go down, 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 right? So this shape, if you will, is called a parabola. And so you're going to hear that word a lot, so don't worry about it right now. But a parabola is the shape being made. In fact, the parabola is the same shape made by any object thrown through the air or that goes through the air because of the effect of gravity. So this isn't true now, but every freshman starting, I think, this year is going to be taking physics instead of earth science. And so physics, you learn a lot about gravity. Gravity is a big deal because everyone knows that gravity has an effect on us. Otherwise, we would float or fly or whatever. So in physics, you learn how important gravity is. And because of gravity, you get this parabolic or parabola shape. And that's what everything does. Even if you shoot a bullet from a gun, it goes in the form of a parabola. Or if you throw a baseball through the air or a football or anything you throw. So, now that I've tried to sell you on the idea of how cool quadratic functions are and how much quadratic functions are seen in actual real world, let's move along. So what is a quadratic function? By the way, this is where your composition book should be out. I need you to take some decent notes today. There's going to be some key vocabulary and just key things that you're going to want to make sure in your notes that you can reference. So pause me now if you're not ready for that. So what is a quadratic function? That's the question of the day, right? What the heck is it? It's any second degree equation. So you're probably thinking, what the heck does it even mean to be second degree? And here's what it is. Any equation that has an x squared term as its highest power. So this is the most important thing. You don't even have to write down the second degree equation part of these notes. Right now, the most important thing to write down is a quadratic function is any equation that has the x squared term as its highest power. So if you see an x squared term in the equation and there's not any power higher than that, there's no third power, fourth power, fifth power, you know that we're dealing with a quadratic. So please write that down. All right, this is called the parent function for all quadratics. So let's talk about what a parent function even means. Okay, a parent function. So what is a parent function? Let's talk about that for a second. A parent function, and you should put this in your notes, and this should be a term that you're familiar with. The parent function is the simplest function of a function family. So I'm going to give you an example of a function that you should be pretty familiar with, which is a linear function, right? So let's just start off this way. We know that y equals mx plus b. But this m here makes the graph do something special. And this b here moves the graph up and down and changes its y-intercept, right? So the m changes the slope, the b changes the y-intercept. But what if we didn't have a value for b? And what if we didn't have a value for m? There's always a value, but we can make it invisible, right? So if we multiply 1 times x, you just get x. So if my slope was 1, I would just have x. And if my b value or my y-intercept is 0, you wouldn't have to say plus 0. You would just leave it as x. So for example, I wouldn't say y equals 1x plus 0, because this 1 disappears and the 0 can disappear, and it all ends up looking like this. So y equals x is actually the simplest function that you can get that still makes a straight line. This is the parent function of a line. Okay, this is the parent function of a line. It's the simplest line with a slope of 1 and a y-intercept of 0. Now let me give you an example of how you would. Every function comes from the parent function. So we all come from our parents originally, right? Biologically speaking, every function comes from the parent function. In other words, if I have a line, y equals x, and I want to make the line steeper, I may make the slope 2. If I want to make the line less steep, I may make it 1/2 x. If I want to make it go in the opposite direction and steeper, I may make it a -2. You see where I'm going with this? So I can always change this value, but the y and the x always stayed the same. We're just adding stuff on to the parent, right? If I want to move the graph up or down, right, of y equals x, I just add a number here, or I subtract a number here. Okay, so we're always taking the original equation of y equals x and we're just making changes to it. And so that's why it's called the parent function. So that's an example of the parent function of a line. So now that we know what a parent function is, or are reminded of it hopefully, let's look at the parent function of a quadratic. F of x equals x squared. Okay, this is the parent function of quadratics. Now don't forget, I'm going to write this up here, and if you don't realize this, I'm going to write it for you. The f of x is the same thing as saying y. That's just function notation, right? So this is the same thing as saying y equals x squared, if that makes you more comfortable, okay? So don't get freaked out by f of x. Quadratic functions can have as many as 3 terms, okay? So here we go. And this is what the terms look like, basically. Okay, this is called standard form. So you're going to want to write this in your composition book. All right, so go ahead and write standard form, and then write this form in your notes. Ax squared plus bx plus c. This form is extremely important. This is what we're going to kind of be talking about today, because this is the most common form of a quadratic that there is. This is what you're going to see most quadratics in, and what you're going to be able to do the most work from. So basically, whenever you simplify anything, it ends up always kind of turning into standard form. Standard form is the most simplified form, if you will. So on the bottom it says quadratics are written in standard form, or descending order. So basically you can see the squared term comes first, and then the x, the one that only has the x in it, and then the one that's just a number. Okay? That's weird. All right, so with that being said, I want you to do some practice. So in between these, go ahead and pause if you don't want to spoil it, but I'm going to ask you to pause on specific ones. So right now, if you want to rewrite this in standard form, pause, and let's see what you got. Cool, so there it is. You can see the 2x squared comes first, followed by -3x, and followed by +1. One thing to keep in mind, and this is going to save you a lot of grief, the signs, for example, this negative sign in front of the 3x always has to follow it. So every sign has a number that it follows. Let's erase that weird thing right there. All right. Let's move on to the next one. Put this one in standard form. This one's a little bit trickier. All right, so there it is. Hopefully you paused me. Remember, the negative sign goes in front of the x squared because you can see it right here. And the 1 up here was positive, but you don't show a positive 1 if it's in the front because you just write 1. So plus and positive mean the same thing. We're just writing the terms next to each other. All right, here's the next one. Try this one out real quick. Pause me. All right, there it is. So hopefully you guys are getting the hang of this. That standard form is written from greatest power to just a constant term. All right. Here we go. Now the question is, you guys wrote down the definition of what a quadratic is earlier, so peek at those notes and just write down which ones of these are actually quadratic. So go ahead and pause if you need to. All right, so is the r of x1 a quadratic? No, you can see that it has an x to the 4th in it. So that x to the 4th, if I back up and get that off the screen, this 4 makes it not a quadratic. Remember, the x squared term has to be the highest power. So that's why this one was a no. All right, t of x, with that being said, is t of x a quadratic? Yes. Now, if you said no, maybe you're thinking, the highest power isn't on the left. This is not asking if it's a quadratic in standard form. It's just asking if it's a quadratic in general. So yes, the squared is the highest power. All right, next one, y equals 8x. No, that's a linear. There's not even a squared power at all. And this next one, yes, this is actually a quadratic in standard form. All right, here we go. So like I said, this is the standard form for quadratics. Go ahead and make sure you have that written down. And there's some specific terms that you should write down also because these terms get thrown around quite a bit. So the first term is the a. We're always putting numbers here. All of these are numbers, right? So the leading coefficient is a number. Okay, let's get rid of that off the screen. That's a number, and so is the middle coefficient, and so is constant. Coefficient literally means number in front of your term. So this is my quadratic term, and this is my linear term, as we'll see right here. Actually, I should have just kept it. And the last one's my constant term. So our a, b's, and c's are the numbers in front of those terms, right? So leading obviously means first, right? So the first term is called the leading coefficient. And then the rest of them, you never really hear middle coefficient too much. But it's your x term, the one with the x, your linear term. And then constant means no x's. So here's an example of what it looks like. Ax squared plus bx plus c right there, standard form, and it shows an equation right below it in standard form. Okay, so what are the coefficients a, b, and c? So pause it. Tell me, what is a, what is b, and what is c? All right, there's the answers. So hopefully you can see that a is your -2. That's the number in front of your quadratic term. Your b is 1 because there's nothing there, so 1 times x is 1x. It's really an invisible 1. And your constant term is a +3. And the names of each term, we'll skip that, but we already went over that. Your quadratic term, your linear term, and your constant term. Honestly, you don't have to worry too much about those. I kind of call them your x squared term, your x term, and your constant. So your constant does come up, so keep that in mind. All right, time for a few questions. What I want you to do is look at these 3 equations and tell me what is A, what is B, and what is C. Oops. Okay, so what is A, what is B, and what is C? Okay, remember we're looking at the equation ax squared plus bx plus c. So pause me and tell me what they are. All right, hopefully you've had a chance to do these on your own. And here are the answers for you. So take a look. Are these the answers you got for the first one? A is 3, B is 2, and C is 7. The one that may have tripped you up, if any of them did, is the last one. A is -3. That's in front of your x squared term, your quadratic term. And your B value is 1 because the 1x. 1 is invisible, and your C value is a +5. All right, here we go. So this is what the graph looks like of a parabola. You kind of saw the one of the motorcycle guy, right? And it looked upside down from this. But this is actually the parent function right here, what the parent function looks like. But the graphs are called parabolas. So you're going to want to write this in your notes in the graphing section of your composition book, right? And draw yourself a nice graph and notice some few things. So I'm going to draw some key points that you could use when you make your graph. Okay, so pay attention to these points and notice how much I go over and how much I go up to get to each point. And then you'll be able to draw some nice graphs. And this one actually on the top is crossing right here. So if you want to put it right there, now you have yourself a nice parabola if you're going to draw it on your paper. Okay, if you draw a dotted line through the center of the parabola, now you have what's called an axis of symmetry. And the very point on the very tip of the parabola, whether it's the top or the bottom, we'll talk about both, that's called the vertex. As you think of these words, symmetry you've heard of before. You've heard of whenever you're a young kid probably. If something's symmetrical, it means it's the exact same on both sides. In fact, you could take that parabola and fold it. Imagine it being a piece of paper and you folded it. The right side of the parabola would land directly on the left side of the parabola. And so this line helps you realize that whatever is happening on one side of the parabola is happening on the other. Hopefully you realize that all the dots on both sides that I drew are all the same height on each side of the parabola. So that's actually going to be very convenient for you coming up. All right, here we go. It uses the word vertices here. Okay, vertice is just a plural for vertex. So don't freak out about that. We just talked about the vertex. Okay, here we go. Let me just put all this information up here for you at the same time so we're not. All right, so there's two different ways you'll see a parabola. Sometimes they open upwards and sometimes they open downwards. Okay, so there's going to be something very specific, a very specific way whenever you see the equation that you're going to know if the parabola opens up or down. So for now, just know that if it does open upwards, you see that it has a vertex of, it's called a minimum. The reason we call that a minimum is because it's the lowest point. Okay, lowest point on the parabola. Okay, if the parabola goes to the lowest point, then it's said to have a minimum. Now on the other side of things right here, we have the maximum, and that's the highest point, right? I don't know why that line happened, but we're going to ignore it. Mr. Norman was having the same issue. I wonder if he fixed it. All right, so that's the highest point, right? So vertex has a maximum, means it's the highest point and goes downwards, and opposite if it goes upwards. Students always confuse this because, well, you'll see why in a little bit. Opening upwards is the normal parabola, so they get confused. I think that one's the one that goes up forever and ever. All right, here's some examples. So we're going to go through this one together, and then the rest of them, I would like you to pause and try them before, so that way you can see if you're learning, right? So this one right here, where is the vertex? So I'm going to draw it because I can. So on there, here's the vertex, right? Okay, but it doesn't want to know that. It wants to know where it is. So there it is, 2, -3, right? I didn't even have to draw it on there because it drew a red dot, but mine's green. So it wants to know what's the coordinates of the vertex. Over 2, down 3, to -3. All right, is this parabola a maximum or a minimum? It's a minimum because it's the vertex is the lowest point. Okay, the lowest point. What is the maximum or minimum value? So all we care is how low or how high did the parabola go? Up or down, the y value. So has a minimum value of y equals -3, because at -3, that is the lowest my parabola goes. Remember, low means, or high means up or down. Now here's the one you guys probably don't know, so I'm just going to show it to you. What is the equation of the axis of symmetry? So if you did draw the dotted line like you see on the screen, it's an invisible line. It's not really part of the parabola, but it helps us out a lot, and it always goes through the vertex, right? And so I want you to notice something that's going to be key coming up. This number, 2, right here, x equals 2, right, is the x value of the vertex, right? So those always match. So if we drew this vertical line, everywhere you look on this line, x always equals 2. So that's the equation. But simply put, the x value of your vertex, x equals the x value of your vertex, is always the equation. All right. You guys do this one. Pause the video, and I'll go over it quickly. So go ahead and pause. All right, where is the vertex? Hopefully you notice it is at -3, 5. And is this a maximum or a minimum? Hopefully you realize this time it's a maximum. And what is that maximum value? Well, how high did my graph go? Up to the 5. Y must equal 5. And what is my equation of the axis of symmetry? Mr. Jones told me it's always x equals whatever the x value of my vertex was. So it must equal x equals -3. Here's the next one. Go ahead and pause. Give it a shot, guys. Make sure you're getting these. You don't have to write them down. All right, where is the vertex? 1, -1. Right? There it is. And a maximum or minimum. This is a maximum. And the maximum value is, a maximum value of -1. Y equals -1. The equation of the axis of symmetry, hopefully you realize the trick. It goes through the vertex at the 1. So x must equal 1. All right, try this one. Should be pretty fast now, right? Pause it if you need to. All right, where's the vertex? Ooh, this one's good. 0, -5. It just went straight down. Minimum value this time. And the minimum value is at -5. Right? And what is the equation of axis of symmetry? X equals 0. X equals 0. By the way, another trick that I don't know if you guys noticed, the minimum or the maximum always has to be where the vertex is also. So the graph, the minimum value always matches the y value of the vertex. See, so y equals, what is that? And then what does my x equal? The same thing as x up here, right? So y value matches the minimum maximum, x value matches the axis of symmetry. If you guys didn't notice that those all match, right? All right, so that's the end of that show. So guys, don't forget that you need to have these notes. You need to submit them. Do a good job on the notes, guys, because you can use them on the test. So remember to have all your good notes for this so you can do the next tasks ahead. All right, catch you guys next time.